All right, so here is part 2 of Notes 5.6. Again, this is the last set of notes in this unit, and I'm just pre-recording this so that I don't have to make it as, any longer than it needs to be during class time. So the next part here is we're talking about zeros and how they relate to the graphs, and how to look at them in terms of polynomials, and then we're going to look at this term called multiplicity. All right, so let's start with the idea of zeros. All right, and I hope that you remember, because I try to say it as often as possible, that zeros, okay, are the same thing as x-intercepts. All right, and they are also the same thing as solutions. Now, I need to be a little more specific about that because it would be the same thing as real solutions. Because when you solve an equation and you get the zeros and the x-intercepts, that doesn't actually show you any complex solutions. All right, so maybe we'll put real in parentheses. So zeros, x-intercepts, real solutions, and another term that you may see at some point is the word roots. Okay, they're all the same thing. So what I have done in the next little screen here is I said, okay, let's use the given graph to answer the following questions. I want to know how many distinct, like how many different but real solutions does the function have? And then I want us to figure out what those solutions are. Okay, and then we're going to turn those solutions into a polynomial. Okay, so if I want to know how many real solutions the function has, then I'm really just looking for how many x-intercepts does this graph have. All right, and this first one has 3, and this second one only has 1. Okay, well then I want to know what are those solutions. Okay, so I want you to tell me what x equals. All right, so this one's at 0, and you can see the tick mark, so it looks like this one's at -2. And if I go to the right, it looks like that one's at 1. And then this one, 1, 2, 3, it looks like this one is at 4. Okay. Now, again, this is the same thing as solutions. So if I were to solve an equation, right, and actually work out what x equals, that's where I would put the solutions on a graph. Okay, so I just need you to make that connection. All right, so now what we're going to do is we're going to take these solutions and we're going to turn them into factors and then turn that into a polynomial. Okay, so let me kind of make a little note here. All right, we're going to turn each zero into a factor. Okay, let me show you how you do that. So you're going to want to write each one separately. So we've got x equals -2, x equals 0, and x equals 1. And what you're going to want to do is you're going to want to rewrite it so that everything is on, like for each individual one, everything is on the same side and it equals 0. Okay, so for the middle one, it's already equal to 0. That one's done. But how would I move a -2 back over to the same side as the x? Well, I would add 2, and then it would equal 0. And then when for the x equals 1, to get the 1 on the same side as the x, I would -1. Okay, and now the piece that is on the side on the left that's equal to 0, that piece is now your factor. Okay, those are your factors. And so you can put them together as a function, right? We're going to call it f of x, and you're going to literally put those 3 factors side by side. Now, typically, when you just have a single x, that usually goes in front, and then it doesn't really matter which factor you write next after that. Okay, so this is a polynomial. All right, this is my polynomial in factored form. Okay, If you are ever asked to get it into standard form, okay, to get standard form, you would need to multiply this out. Multiply it all out. Okay, so what do I mean by that? All right, so what I mean is you're going to have to multiply all these factors together. And there really is a certain order you should do it in. Okay, you should really try to FOIL, all right, your binomials together first. So we're going to do first, outer, inner, last. And then you're going to add like terms. And then you're going to come back and you're going to multiply that by the x that you haven't done anything with yet. Okay, so then we're going to distribute the x, and we're going to get x cubed plus x squared minus 2x. And then we're going to put f of x in front of it so that it's a function again. And that is our function in standard form. That's our polynomial in standard form. Okay, so let's go back and do the second one here, so we have a parabola here, and we only have one solution. All right, and so we're going to take that solution and we're going to turn it into a factor by making it equal to 0. Okay, now when I write that as a function, okay, I just have the one factor, right? But the problem with that is that would not make a parabola if I were to graph it, because there's no x squared. Okay, and so what's happening here is that to make this turn into a parabola, a quadratic function, we actually need to square the entire factor. Okay, and that is actually now in factored form. So this is factored form. Okay, and we had to square it because if we didn't square it, it would not match this graph, and you can certainly use Desmos to check that. Okay, now if I wanted standard form for this one, all right, keep in mind that if you have something squared and you want to work it out, you have to actually write it twice, okay, and then you can FOIL it. So first, outer, inner, last, and then combine like terms, and we have nothing else to distribute, and so that is our function in standard form. Okay, so that's what we call standard form. Whoops. All right, so what we're going to see here in just a minute is that when you actually have the same factor twice, okay, like, so if I were to solve this, think about how we, how we solve things before. When you have a square, you just have the same factor twice, and so technically you only set it equal to 0 once, and you only get one solution. But when you have the same factor twice, we actually call that a double root. Okay, so that's where you might hear the word root come in. When you have the same factor twice, you get a double root, and that actually affects the graph. Okay, so you can see that for all of these over here, each factor or each zero, there was 3 different ones, and when we multiplied it together, we got a cubic function. Okay, but like each one of them actually crossed through the x-axis. But over here, this particular solution, or 0, it did not actually cross through the x-axis. It kind of touches it and then bounces and goes back up. And so we're going to talk about how you could determine what actually happens on the graph just based on the factors here in just a second. And that's called multiplicity. Okay, so for this part, again, we were just picking the zeros off of the graph, turning them into factors. Okay, and so we were writing a polynomial in factored form. And then if I ever ask you for standard form, that means you are going to have to multiply it all out. Okay? All right. And then the last part of our notes is what I was just talking about, this term multiplicity. Okay? Now, multiplicity comes from the word multiple. Okay? And so the multiple of a zero is just equal, it's equal to the number of times that that factor occurs. Okay, so let's kind of work through it so you can see what I'm talking about. So here is a polynomial, and the first thing you're going to want to do is write it in factored form. So we're going to factor this thing. So I'm going to take out an x because that's the GCF. Okay, and then let's see, that's still going to be a 6. That's still going to be a 9, but everything got rid of an x. And then I notice that this is what you would call a normal trinomial. So I should be able to unfoil it because I'm thinking in my head what multiplies to be positive 9 and adds to be negative 6. And we get negative 3 and negative 3. Okay, now I kind of ran out of room, but remember when you have the same factor twice, you can actually write it once with a square. Okay, so there is my polynomial. I guess technically I could keep the f of x in front of it. All right, there is my polynomial in factored form. Now, if I were to find the zeros, remember that means take each factor and set it equal to 0 and solve it. But if you get the same one twice, you only have to solve it once. Okay? Now, the multiplicity is literally how many times did that factor occur. So the x only occurred once. So it has a multiplicity, and I'll abbreviate that, equal to 1. But the 3, that factor occurred twice, and you can see it here in the exponent. So that one has a multiplicity of 2. Okay? All right, so multiplicity is literally how many times does each factor occur. Okay? Now, let's talk about how that, like how you can pick that out maybe from a graph. Okay, or what does multiplicity do to a graph? All right, so what if I asked you to actually graph this equation? Okay, well, we know where the zeros are going to be. All right, that's at 0 and 3. But if we want any other information, we're going to want to open up Desmos. Okay, so I'm going to open up Desmos, and I'm going to type in f of x equals, and remember you don't have to type in the f of x if you don't want to, x cubed minus 6x squared plus 9x. Okay, and remember in Desmos you want to get a couple pieces of information. You need your x-intercepts, you need your maxes and your mins, okay, which some of these all happen to be the same. So I really only have 3 important points, okay, and you can zoom out. There's no other curves, right? This is cubic. It should look kind of like an N, so there shouldn't curve in any other way. So again, my points are 0, 0, 1, 4, and 3, 0. Okay? All right, so I've already got my 0, 0. I need a point at 1, 4. And then I don't know if y'all can hear my dog barking, but she's going crazy. I even have the door shut, but okay. And then 3, 0. All right. And so then I'm going to try to draw the, whoa, this is really hard with this little tool I have here. Okay, so I just need to make this N shape here. All right, so that looks kind of like what it looked like in Desmos. Okay, and what I want you to notice is that when x equaled 0 and the multiplicity was 1, the graph crossed through the x-axis. Okay, but at x equals 3, when the multiplicity was 2, all right, the graph, for lack of a better word, bounced off of the x-axis right there. So it touched the x-axis, but it went back the way it came. And so that actually happens all the time, depending on whether the multiplicity is an even number or an odd number. So if the multiplicity is odd, so it's 1, 3, 5, 7, whatever, if the multiplicity is odd, then the graph crosses the x-axis at that 0. Okay, and so that's this one here. And then if the multiplicity is even, the graph bounces on the x-axis there, and that's this one. Okay, so those are the terms that I want you to use, crosses and bounces. And so what we're going to do now is, without looking at the graph itself, you're going to find the zeros. So I've given you some crazy, one of these is like super crazy. All right, you're going to find the zeros. You're going to tell me what their multiplicity is, and then how does that affect the graph? Okay, all right, so the first one here is actually in factored form for you. Okay, so when you find the zeros, all you have to do is set each factor equal to 0 and solve. Okay, so on this one we're going to minus 1, and on this one we're going to divide by 2. And then on the last one, all right, okay, so my zeros are -7, -1/2, and 4. And the multiplicity is just the exponent of each of those factors. And if there is no exponent, it's a 1. So the multiplicity for the first one is 2, 1 for the second one, and 3 for the third one. And then for the effect, all right, well, if the multiplicity is odd, okay, let me scroll back up a little bit. If the multiplicity is odd, the effect is that it crosses. And all you have to do is write cross. Okay, and this one is also odd. Okay, and if the multiplicity is even, the graph is it bounces. So you're just going to write cross or bounce, right? And that means if I were to graph it, at those 3 places, I should either see the graph cross the x-axis or bounce on the x-axis. Okay. Now, number 17 is a little different because I did not give it to you in factored form. Well, you can only find multiplicity in factored form. Okay, so we are going to have to factor first. Okay, we are going to have to factor. So let's see. I've got a GCF. All right, but that doesn't change my numbers. And then let's see, that's an x squared, so it looks like I should be able to unfoil it. And if you're picking out multiplicity, you're going to have to be able to unfoil. So let's see. What multiplies to be -8 and adds to be -2. And then when I set each one equal to 0, I get 0 for that one because the square root of 0 is 0. I get 4 for the next one. And I get -2 for the last one. Okay, so I have a 0, a 4, and a -2. Now, the multiplicity, you need to go back to your factors and look at your exponents. Okay, well, the x was squared, so it has a multiplicity of 2. All right, and then the other ones did not have any exponents, so they're just 1. All right, so the one that is even is a bounce, and the 2 odd ones are cross. Okay, and then the last thing that you're going to need to be able to do with multiplicity is, what if I tell you what the zeros are and I tell you their multiplicity, and then I ask you to write a polynomial? Okay, now the good thing is you're only going to have to write it in factored form. Okay, you're never going to have to multiply these out unless it's like a bonus question or something. All right, so if we have a 0 at -6, you first need to understand that that means x equals -6. And then if we have another one at 2, then x equals 2. And you're going to turn these back into factors, all right, by making them equal to 0. So we add 6 to make that one equal to 0. We minus 2 to make that one equal to 0. And then we're ready to write our polynomial. So we have to make it a function. We're going to put our two factors, and then we're going to go back and pick up the multiplicity. Well, the -6 had a multiplicity of 2, which meant that factor needed to be squared. And the 2 had a multiplicity of 1, so that factor actually doesn't need an exponent at all. And that's all you have to do for this section. Okay? And last but not least, all right, let's see. We have a 0 at x equals 0. We have 1 at 2/3. Notice I'm skipping over the multiplicity part right now. And then we have another one at -4/5. So the first thing we need to do is turn those back into factors. We need to make them equal to 0. So this one is already equal to 0. Now with fractions, right, you can't just say x minus 2/3 because that's not what factors look like. So you're actually going to have to do this in 2 steps. You're going to need to get rid of the bottom number first. So we're going to times by 3. And then you can move the other number over. So in this case, we would minus 2. All right, so on the next one, we're going to times by 5. And then that will show us that we need to add 4 to make this thing equal to 0. All right, so now we are ready to write our polynomial. And if you have an x equals 0, that factor should always go first. Okay, so this is a factor, this is a factor, this is a factor. Okay, so I'm going to write my factors down, leaving a little bit of space in between so I can squeeze in my multiplicity. All right, so then I'm going to go back and get my multiplicity. And the first one has a multiplicity of 4. Then the 2/3 has a multiplicity of 2. And the last one has a multiplicity of 3. And that's my polynomial. It's still in factored form, and I certainly would never ask you to multiply something crazy like that out. Okay? All right, so I hope that that makes sense to you, and then you'll be able to answer questions about multiplicity. And that's it for this set of notes.